So absorptive and post-absorptive states. What we're going to do, we're going to compare them. We're going to compare the main features. So what is absorptive state? Absorptive state comes after the meal. Does that make sense? Hence, absorptive. Absorption of nutrients. Does that make sense? So let's figure out which processes are up-regulated. So first of all, when you eat, what happens to the blood glucose levels? Immediately after the meal, your blood glucose increases. As your blood glucose increases, your insulin levels change out. They increase as well. Remember that insulin stimulates glucose uptake, right? Does that make sense, this part? Glucose uptake goes up, right? When your glucose uptake increases and glucose becomes more available in the cells, like there's more glucose in the cell, are you with me? How do you think availability of glucose in the cells changes the levels of glycolysis?
Or glycolysis increases.
Glycolysis, yes, glycolysis will increase. So basically, you have more glucose to break down, and therefore the breakdown of glucose will go up. Does that make sense? Now, remember from our previous picture, not all glucose is broken up, right? Some of it is going to be stored in the form of, remember, glycogen. Okay, so glycogenesis will increase as well. Are you following me? Now, since not all incoming glucose can be, brain fart. Not all glucose can be stored in the form of glycogen. The long-term storage is in the form of what? Fat. So lipogenesis goes up too. Are we clear? Good? And now, what about, so we figured lipogenesis, I'm trying to think what else. And finally, check this out. We consume proteins, right? So we have a lot of amino acids. What's going to happen to those amino acids when they are in the blood?
They're going to be taken up by cells.
Yes, so amino acid uptake is going to be increased, and as amino acids become more and more available in the cell, what's going to happen to protein synthesis? How is it going to be affected?
It will also increase.
Yeah, because you have more substrate for it. Does that make sense? So this is absorptive state, and you see, except for glycolysis, really, all other processes that we will look here at are anabolic. They are synthetic. Does that make sense to you? Now, what about post-absorptive state? So first of all, when does it happen? Huh? Well, not necessarily before meal, but like when you're hungry, right? So I mean, I'm not teasing, but like I ate my lunch. I am now in absorptive state. I don't know how long ago you had something to eat. You might be in the post-absorptive state. Does that make sense? So, your blood glucose is what? Which means, which hormone goes up? Remember, glucagon increases. Look, it's a lot of information. I'm not being critical here, right? Now, what is the effect of the increased glucagon overall on the blood sugar?
Decreases on blood sugar.
Insulin, you mixed it with an uptake, I think, because insulin decreases blood sugar, right, by taking it into the cells, while glucagon increases blood sugar by somehow releasing glucose from the cells. Am I clear? So you have very little glucose in the cells. Am I clear? If you don't have enough glucose in the cells, what's going to happen to glycolysis? It's going to be decreased. Now, let me ask you right away, all the processes that go after glycolysis in this column, what's going to happen to these four processes in a post-absorptive state? They're going to go down. They're going to go down dramatically. Does that make sense? Because it's the opposite. Now, which processes will increase? So, how can you get the glucose? From what? You can get it from glycogen. So, glycogenolysis. Okay? Does that make sense? Now, can you synthesize glucose from scratch? You absolutely can. So, gluconeogenesis will be also increased. Now, you technically can get it from fat to some extent, so lipolysis. Okay? Now, if you are really, really hungry, like if you are literally starving, not like people are literally starving before they go to the restaurant. No, you're literally starving. So you run out of glycogen, you run out of fat. What are you starting to break down? Protein. Okay? Does that make sense to you? We good? We clear? So you should be able to tell which process is characteristic for which state. Does that make sense? So I can ask you, which of the following processes is increased in the absorptive state? And I give you a list, and you're like, I don't know. Which of the following processes is increased in the absorptive state? Lipolysis, gluconeogenesis, glycogenolysis, or lipogenesis. So you're like, lipolysis, gluconeogenesis, glycogenolysis are all increased in post-absorptive. In absorptive, only lipogenesis. Okay? Does that make sense? Any questions about this one? No? Okay.